Section 5.3, problem number 63. We need to find the exact values for sine of theta over 2, cosine of theta over 2, and tangent theta over 2, given that our cotangent of theta is 21 over 20. And our theta is between pi and 3 pi over 2. So this information tells me that our angle is in quadrant 3. So my triangle is oriented like so, with our theta reference angle here. Cotangent is the inverse of tangent. Tangent is opposite over adjacent, so cotangent would be adjacent over opposite. So the adjacent is the 21, the opposite is the 20. Then I can use the Pythagorean theorem or Pythagorean triples to find this third side is 29. The 21 and the 20 are both going to be negative because we're in quadrant 3. And let's see, that's all I need from that triangle. Now let's check these formulas and make sure I have all the information I need. So sine of pi over 2, that's the half angle for sine. That identity is the square root of 1 minus cosine of theta over 2. And our cosine, oops, sorry, wrong color. Cosine of theta over 2 is the square root of 1 plus cosine over theta of 2 over 2. And the tangent, we do have a half angle identity for the tangent, but it tends to be easier as long as we're finding sine and cosine anyway, to just use that relationship with tangent. So I think we'll try that and see how it goes. So let's plan on this. So looking at my formulas here, the only thing I need is cosine. That's the only thing I need from that triangle. So going back to my light blue. So from this triangle, the information I need to get is that cosine is adjacent over opposite. So that'll be, adjacent over hypotenuse, which is negative 21 over 29. So I'm going to plug that into our formulas here. So first we'll find sine of pi over 2 equals square root of 1 minus negative 21 over 29 all over 2. Getting my common denominator, I get, still under my big giant square root, I get 29 over 29. Minus a negative is a plus, which gives me 50 over 29 divided by 2, which is the same as times 1/2, which gives me, let's reduce that a little so that 2 and 50 cancel. And I get 25 over 29. That 25 comes out of the square root very nicely as a 5 over radical 29. Okay, we'll leave that unrationalized. And then cosine of the half angle. Very similar process, so I'm going to kind of skip to the punchline here. I'm going to skip to where I have the sign to change, so that's kind of right here. I'm just going to copy that and change that plus to a minus. So I get the radical 29 over 29 minus 21 over 29 all over 2 equals the radical 8 over 29 Again, divided by 2 is the same as times 1/2. So that gives me, again, I can reduce. So that 2 and the 8 can reduce to 4 and 1, which gives me 4/29, and that 4 comes out very nicely out of a square root as 2, and I still have a square root of 29 in the denominator. Now we need to use our quadrant to determine the signage. So let's do that in orange. Okay, so our angle theta is in quadrant 3. And that means that our angle divided by 2, or theta divided by 2, is going to be in quadrant 2. Thinking about, okay, so if pi is 90 degrees, and theta is between 90 degrees and 270 degrees, then half of theta must be between 45 degrees and 135 degrees. So that's in quadrant 2. And quadrant 2 has sine would be positive. So we'll leave that purple one with a positive. And cosine will be negative. So I need to put a negative out in front for this one. So I'll just kind of put that negative all through here. Okay. All right, last step is to find the tangent, and we already have sine and cosine, so let's see if those divide nicely. They have the same denominator, so if I take this guy divided by that guy, I end up with negative 5/2, since those denominators will drop out when I divide them. And there's my final answers. So sine of theta over 2 equals 5 over radical 29. Cosine of theta over 2 is negative 2 over 29, radical 29. And tangent of theta over 2 is negative 5/2, or 2 1/2.